Our free lesson on light and optics and all about the MCAT. So we're super excited to have each and every one of you here tonight, and really looking forward to spending pretty much the next, we'll say hour, 45 minutes, 2 hours or so together, talking about the MCAT, talking about light and optics, all sorts of fun stuff. So we got a great time planned for all of us, and really looking forward to it. I'm joined tonight by with a couple of my great colleagues, actually a number of them. So we've got Ari, Ashwarya, Mary, Mike, and Nikolai, all here, all veteran MCAT instructors, ready to answer your questions as we go. And we're really looking forward to kind of getting things going here and really having a great conversation and a great evening. My name is Petros Manassi. I'm the director of our pre-medical programs here at Kaplan, and also a veteran MCAT instructor myself. So really happy to be here. Really got to wear 2 hats tonight. I got to play host and teacher. For those of you that were here last night, I got to do one of those 2 things, and tonight I get to do both. But as I said, if you got questions, type them into the chat. We'll be answering them as we go. So lots of fun planned for sure. To kick off the fun, we're actually going to be giving away a $50 Starbucks gift card later on tonight. So if you haven't already done so, click on the link at the top for the giveaway and enter in your information, and we'll be announcing that at the end of tonight. So hopefully one of you here, well, I know for sure, one of you here is going to be receiving a $50 gift card to Starbucks. Maybe something you can use when you're studying away for the MCAT and needing that little extra caffeine boost, as it were, along the way. So let's dive right on in and get things going. We're going to talk tonight about the MCAT. We're going to talk a little bit about strategy. We're going to do some content instruction. We're going to pretty much do a lesson from the MCAT channel. The MCAT channel is one of the features in our MCAT programs. It gives you the opportunity to attend live sessions in addition to your core classes from a variety of topics, from topics that kind of come from all over the MCAT. So we're gonna do a whole session on that. It's gonna be about light and optics. We'll do a little bit of coaching at the end to help you figure out. I mean, really what the coaching is, to be plain and simple, is to kind of give you a sense of what you need to be doing next in order to get ready for the MCAT. We don't need to wait to have that conversation till the end. Like, as you have those questions, let us know. That's what we're here for. So, if you got questions, just type them in. We've got a formal Q&A time designated for the end, but really the Q&A is going to happen throughout the course of the night. So, just ask your questions and we'll take it from there. Couple things to highlight though. One is the importance of the MCAT. I get asked this question a lot. I was just actually at a conference, and I think I got this question more times than I cared to. How important is the MCAT in the medical school admissions process? Very, very important. In fact, we survey admissions officers year after year, and every year the MCAT comes back as being the most important factor in the medical school admissions process. And it makes sense because it's the one thing in the process that is the same for everybody, right? It is a standardized exam. Everyone is being measured against the exact same benchmark. It is also an exam, and more importantly, I should say, an exam that is not actually just being used to weed out candidates. It's actually used to predict how successful you will be in your first 2 years of medical school curriculum. So it's actually an exam that is measuring your potential and really the curriculum from throughout medical school. So, when you think about the MCAT and why it's important and why you need to dedicate time to it, it's a lot of reasons, and it's about getting in, but it's also about really showing your potential to the schools. Your undergraduate GPA is number 2 on this list as far as the ranking from the admissions officers, and part of the reason why it's number 2 and not number 1 is that it is not the same across all undergraduate institutions, right? Everybody takes different courses from different professors at different schools, so there's a lot of variables in there. With the MCAT score, it's the one thing that we all do, and it's the same. So it allows medical schools to really kind of use that as the beginning of their decision-making process. And of course, all the other factors do play a large role. Namely, the personal statement here is down at the bottom of the list. I asked a couple folks, admissions officers, about why is it at the bottom of the list. It makes sense. They don't get to the personal statement unless the MCAT score and the GPA are at their at a level that makes them happy to continue on as an applicant. So really, really important to make sure that we put the right emphasis onto your MCAT prep. Now, I think we put a poll up earlier, and we'll get the results of that poll. But depending on when you're taking the MCAT, the good news is there's always a way to prepare. In fact, the great news is that the MCAT is the most preparable exam that is in fact out there. So if you're kind of wondering, like, can I actually prepare for this? The answer is yes, you very much can. And in fact, the reason why it's so preparable is because it's pretty public as far as what is fair game on this exam, and there is a very, very kind of defined way of getting yourself ready for it, and we're going to show you some of those ways later on here tonight. I see about 47% of you or so are taking the test in April or May, which is good. For those of you taking it in April, that means you're taking the test either this Saturday or this Friday or Saturday. So maybe here is not the best place to be because you might want to be getting those final polishes in for the test. But we wish you all the best of luck. For those who are testing in May, plenty of time still to prepare. Of course, if you're testing in June or beyond, definitely now is a kind of ideal time to get started as far as your preparation. I do see a good number of you are going to be testing next year, so that's kind of awesome. And a good number of you, about 75% of you or so, are actually applying this cycle. So that's kind of cool too, because what that of course means is that this will all be done relatively soon. So cool stuff. So that's the MCAT. If you got questions about that, let us know as far as its importance in the process. At the same time, as an exam, it's a really cool exam. I don't want to underplay this at all. It's a really cool exam. It's a hard exam, but it's a cool exam because you're actually being tested on multiple subjects in any one given section, which is very different from how we learn as undergrads, right? So, when I took organic chemistry, when you took organic chemistry, the way that it worked was you were being taught organic chemistry by an organic chemistry professor who wanted you to learn the organic chemistry. You get to the MCAT, and now that organic chemistry is being applied to biochemistry. When you took physics, you learned it from a physics professor who wanted you to learn physics. You get to the MCAT, that physics is being applied to biological systems. So you can see it from the names of the sections that all these sciences are very, very integrated, right? There's a very kind of high level of integration that occurs on this exam, but even more importantly, the MCAT is not an exam that is going to reward you just for knowing something. It's an exam that's going to reward you for being able to apply that something, right? It's really, really important to kind of remember that the points on the MCAT come as a result of your ability to apply the knowledge that you have. It's very, very much testing the skills that a physician has to use on a daily basis. Physicians have to walk into an examination room with all their knowledge. They get new information from the patient. They're able to take the information from the patient, combine it with the information that they have, the knowledge that they have from their studies and from their practice, and they're able to reason out a diagnosis. You're doing the same thing. You're taking content that you know, you're being presented with new information in these passages, and you're being required to reason out an answer choice. So very much the same critical thinking skill that you're going to be using really for the rest of your life as a practicing physician throughout. So something that's important to kind of keep in mind as you're going through this. The CAR section, the critical analysis and reasoning skills section, that has no science. So in fact, that is all purely based on how well you're able to critically reason and you're able to analyze the arguments that are being made in these passages. So something to kind of keep in mind as you're looking through this, you can't rely on content for that section. You have to really focus onto those critical thinking skills, as it were, and as you're working through. So, that's what the test looks like as far as an exam, as far as the content or the score distribution, I should say. It's scored from a 118 to a 132 on each section. That gives you a combined score of 472 to 528 total. As far as the exam, the 500 is the 50th percentile. So that means average, right? That means half the students who took the test scored below that number, half the students who took the test scored above that number. The most competitive applications and the most competitive schools require numbers much higher than the 50th percentile. In fact, the average of all students who have matriculated into medical school is around the 85th percentile. So, just to put things in perspective for you, you want to kind of maximize your chances of admission by having a nice solid MCAT score. Now, that's not to say that you have to have that score in order to get in, because it is an average. There are plenty of students that have been admitted with numbers below that. There are plenty of students that have not been admitted who have numbers above that, because there are other factors that come into play. But, why not give yourself the best chance, the best foot forward? I mean, that's what we're here for. That's why you're here. That's why you're spending the time here, because you want to improve your score. One note that I will give you, I give this to all of my students. You are all my students here tonight, and now are one of my students. Do not get fixated on the number. It is so easy. Who would agree with me on that? That we get like fixated onto numbers, and we just get stuck on the number, and we stop thinking about all the other things that have to go on. That's very normal, right? Very, very normal. What you want to fixate on, and I want to kind of put this out there for you right now, is fixate on getting more questions correct. That is how you get a higher score on the MCAT. It sounds very, very superficial, but it is highly accurate. It's so easy to get hung up onto the number and forget that what we really need to get hung up on is getting more questions right? Getting more questions right, that's going to get you the higher score. And so really, really important to kind of remember that and not get fixated on the number. The number will come if you do the work, and that's what we're here for. That's why we love doing what we do, is helping students like yourself make it happen. At the same time, when you think about the science content, I alluded to this earlier, but just to kind of dive into this a little bit more, the content's all over the place, right? So in one section, in the biochem section, you're being tested on biology, on biochemistry, on general chemistry, and on orgo. In the chem phys section, you're being tested on biochemistry, general chemistry, orgo, and you're being tested on physics. So, there's a lot happening in these sections. I mean, a classic example of the integration of these sciences is the circulatory system. Circulatory system, we learn that in our biology classes, right? So that is a bio 1A type system that we learn, but in reality, it's got a lot of physics in it, right? If you think about the circulatory system, it's nothing more than a pump that is hooked up to a bunch of pipes. Those pipes happen to be, arteries and veins and capillaries in your body. And you got a fluid that is going through those pipes, and you're being measured. You got to measure the velocity of that fluid. You got to measure the pressures that are there. There are all sorts of factors that are coming through. So, important to start to think about the integrated nature of this exam, even more so as you're getting ready for this test, because it's very, very different from the way that we have traditionally learned this material. So with that said, we look at this last slide here before we dive into the main stuff, and that is the skills that the MCAT is testing you on. So there's the content areas, and then there are the MCAT skills. And really each MCAT question is at the intersection of one of these skills and a content area. And the way that we teach our students, and the way that you're going to see this tonight, we're going to do a lot of content review, but the way you got to start thinking about these things is, how can I improve my work at those intersections? How can I become a better problem solver relating that to the knowledge, the content that I have? And that's really kind of a core skill that you're going to want to work on. And these are the skills that we work on and we dive into quite deeply in our courses, and so in the way that we prepare students along the way. So we're gonna be giving you a preview of that here tonight. And if you guys have questions about anything and everything, let us know, right? So let us know, and we'll be taking it from there. All right. So with that said, I am going to move us over to our light and optics slide. So give me a second here while that happens. Magic of the online classroom. There it is. So let's talk about light and optics. So get out your notebooks, put on your thinking caps, all those fun things. Ari, Ashwarya, Mary, Mike, Nikolai, and I, we are ready to rock this thing and talk all about light and optics as we go. So here it is. First and foremost, here's what we are going to be covering. We are going to cover the components of the electromagnetic spectrum and good old visual light. And we're going to be talking about ray diagrams. Now, tell me if this is you, and put this into the chat. Who really doesn't like ray diagrams and mirrors and lenses and all the images, whether they're virtual or real or upright or at infinity, they're going to show up? Who's kind of getting a little bit nauseous maybe as we so not necessarily everyone's favorite, right? Not necessarily everyone's favorite. Here's the good news. It's something that you can conquer, okay? Something you can conquer. And more importantly, there's a real kind of formulaic way of doing so. So we're gonna walk you through those, as it were. But what I want you to also be aware of is that it's not just about knowing what these diagrams are. It's going to be a lot about taking a question and knowing which diagram you're going to have to use. Because on the MCAT, they'll never just say, draw us a ray diagram, right? That's not how the test is designed. I wish that's how it was, because then you could just memorize these straight through and you'd be fine. But the reality is you have to look at these things from the perspective of how they're going to be tested. Remember what I said earlier, it's all about the application, right? The application of the material. That is what is absolutely going to be key. So let's start with the discussion about the electromagnetic spectrum and the good old properties of light, right? So here's our good friend. This is the diagram, and we're going to see this here in a second. So don't worry, it's going to disappear here. But this is the diagram that we're going to be looking at, and really what we care about is this part right here, right? The visible spectrum of light. So good old white light, in fact, is made up of many, many colors, right? So this is that visible spectrum of light. And so when we're looking at light, we have to remember that, okay, we've got all these colors, and sometimes we're specifically looking at one individual color, right? To figure out what color that light ray is going to be. Now, something to kind of put ourselves mindset-wise, if you are looking at something and it looks red, what colors is that object absorbing? If I see something that is red, what colors is that object in fact absorbing? Not reflecting. What colors is it absorbing along the way? It's absorbing everything but red. Exactly, right? So if we're seeing something red, that actually means that it's absorbing all the colors except for the color red, right? If we're seeing something that's blue, it's accepting, or absorbing, not accepting, absorbing, we're just talking about acceptance, right? It's absorbing everything except the blue. So when we see a certain color, that is in fact the reflection, right? This shirt that I'm wearing is like a light purple. So that means the shirt is absorbing all the colors except for that light bit of purple, right? That's the key to remember as we're thinking about this visible spectrum of light. We sometimes lose sight of that, so I wanted to make sure that we were comfortable with that. Now, when we look at light, light's pretty awesome. We have a nice formula that we can use, and that formula is C equals F times lambda. Okay. Now, C equaling F times lambda doesn't mean much, but if we think about it in kind of the true sense of what it's representing, the C is, of course, the speed of light. The F is the frequency, and frequency is 1 over, what is that 1 over? It's 1 over good old seconds. And then the lambda, that is your wavelength, which is measured in meters. So the speed of light would be equal to meters over seconds, which makes sense, right? So from a units perspective, we got this, right? So really, if you forget the formula, just think, okay, how can I get to meters per second, right? Now, the reason why we use C as opposed to V, velocity, is of course because of the fact that as far as light is concerned, we're looking at this as an approximation, and we can think of it as being a constant value, right? So we have a constant value as far as C equaling the frequency times lambda. Now that of course does change depending on the medium and all that good stuff, but more importantly, what we care about really in this case is that C is equal to frequency times lambda. All right, so write that down. Don't forget that formula because we're going to be using that formula quite a bit. Now, as the frequency is decreasing, as we're going from left to right on this chart here, that means we are increasing our wavelength. And you can see that, right? So here's the frequency over here. It's 10 to the 24th power. Down here is 10 to the 0 power. But what's happening in the wavelength is the wavelengths are getting longer, right? So we have 10 to the minus 16 up to 10 to the 8th. Right? That's a really long wavelength when you think about it. And we'll figure out what's over there in those really, really long wavelengths here in a second. So the opposite is true on the other side. As frequency increases, as we're going this way, then the wavelength is, of course, going down. And that makes sense, because if one is going up, then the other one has to go down in order for what to remain constant. What's got to, if one's going up and one's going down, that's going to allow good old speed, right, the velocity, to stay at a constant, which is perfect, right? So this makes sense. You guys got it. You're on it. High fives. You're good, right? So the reason I share this with you is that if you ever forget kind of why the speed of light is constant, just think of the frequency and the lambda having this kind of inverse relationship to each other. It's kind of like, not to conflate the sciences, but it's kind of like PV equals nRT, right? If the nRT side is staying the same and the pressure is going up, then the volume must be going down, or vice versa, right? So it's just like any other formula that we know and that we work with and that we've seen over and over again. All right, so keep that in mind, right? Keep that in mind as it were, and as we're going through this. Now, as we look through this, we say, okay, we care about this little spectrum here, but over to the left of the visible light, you've got your gamma rays, really, really high frequency. You've got X-rays, also relatively high frequency. You've got UV light, high frequency, right? These are all relatively high frequency. Gamma rays, of course, super, super high frequency. We don't want to be around those too much if we don't have to be, okay? At the same time, on the right side, you've got the infrared light, you've got microwaves, so literally the microwaves that you have in your microwave oven, this is their frequency range and their wavelength range. AM radio, FM radio waves, and then of course longer radio waves that go over here. The reason why we're able to communicate with folks that are in outer space is because we're using radio waves, right? These are really, really long radio waves. They've got relatively low frequencies, right? So they're able to travel pretty far distances, and that's why we're able to use the radio and have those conversations with our friends who are in outer space. I think there are only a couple of them right now, probably in the space station, but that's the bottom line. Anthony asked a good question earlier, which I wasn't ignoring. I just wanted to find a good time to bring it up. The question was, how many formulas should you know? Pretty much, I mean, there's a ton of formulas you're going to need to know, but pretty much any formula that you will need to know, the best way to learn those formulas is to practice using them. So, just to kind of put things in perspective, it's one thing to sit down and memorize a whole bunch of formulas. It's another thing to actually practice using them. So, that's really where the reward is. That being said, if you're in our course, you have something called the quick sheets, which actually has all the formulas on it. That would be the list. It's 24 pages, of formulas and topics or recaps of certain concepts and reactions and all those things. But there are quite a few. You'll see more, of course, in the physics area, and then you got a lot of reactions that you have to know, of course, and be able to identify reaction types for organic chemistry specifically. So, quite a bit on your docket. But again, the way to learn it is to practice using it. That's really going to be your key part to all this. Now, when we look at the visible light spectrum, again, we care about this little rainbow that's here in the middle. The range of light and the colors goes from violet to red. All right, so we've got still C is equal to frequency times lambda. That hasn't changed. As the frequency is decreasing, the wavelength is increasing. So between this blue violet over here and the red over here, which one has the longer wavelength? The violet light or the blue light? Which one's going to have the longer wavelength according to our little chart here? Which one is it going to be? Good old red, right? Good old red. So that is the key. Is the good old red is going to have the longer wavelengths in this, which is why, back to the reason why we sunburn is because UV light is right to the left over here of this violet light that we see. So that's what it comes down to. So when we look at the light rays and the ranges, we've got red and violet on the ends, and then you can kind of fill in the rest if you think about it. So you've got orange over here, and what mixed with red gives you orange? Good old yellow. Well, that's what goes right over there. And yellow, when you mix, or if you think about violet, violet is going to be really, it's red over on this side and blue over here. That's where you get the blue, and then blue and yellow, of course, make green. So here's your range as far as your colors are concerned. It's violet, blue, green, yellow, orange, red, right? So those are the letters, or the colors, I should say. Definitely memorize this order. If for some reason you ever forget this order, just remember that violet is on the left, red is on the right, red, right, the R's, that's the way you remember that. And then you can fill in the rest if you remember your preschool color mixing. I'm not trying to make the MCAT about preschool color mixing, but that's really what it is, right? When you're learning to mix colors in preschool, you're actually kind of learning about the visible spectrum of light. So yes, that stuff was important at some point. And yes, you can remember, Roy G. Biv, one way to remember it. But knowing the order, super important, of course, to keep things going, as it were. All right, so that's what we have as far as this visible spectrum of light. The way you're going to get questions on it, though, is going to be a little different, because they're not going to just say, wavelength is 480. What color is it? Right? I wish that's how the questions were. That's not what they're going to do. This is how they're going to test you on the MCAT about your knowledge of the colors of light. So here's what it is. Here's an example question for you. We're going to bring out a poll here in a second, but I want you to follow through on this process. Question says, elevated wakefulness has been heavily tied to exposure to blue light. We say, okay, that sounds horrible. And there's a reason why you don't want to be looking at too much blue light, right? They sell glasses now to block out the blue light, right? So, blue light's not great. Which results in the depolarization of the norandrogenic fibers and the locus coeruleus via the opening of the nonspecific cation channel rhodopsin 2. Now, that's a lot of information that's being thrown at you. You're looking at a question like this, and let's just pause for a second, because again, I don't want you to jump to the answers here. If we pause for a second and think about this, this sounds like bio, right? This sounds like biochemistry, bio. We've got channels, we've got cations. I mean, there's a whole bunch of kind of biological science that's coming through, right? Lots and lots of biological science that we have to be looking at. But the problem is, right? The problem is that's not actually the question. The question says, which of the following ambient settings would be least effective in supplementing the treatment of insomnia? And we say to ourselves, well, let's think this through, because this is a critical thinking question. They want to know what we want the ambient settings to be that would be least effective. Now, the least effective in treating somebody with insomnia, insomnia, of course, is not sleeping well, right, or not being able to sleep. If you want to be least effective at that insomnia, and supplementing insomnia, would you want blue light, which causes all these bad things to happen, or would you want red light? Which side would you want? Let's just think about it there. We're not even going to look at the answer choices yet. So just purely on a conceptual basis, do we want blue or do we want red? We probably want blue because that's going to be the least effective, right? If we want to be effective, we would want red. But since the question is asking us what's least effective, well, the least effective thing is going to be this blue light that they just told us about. They told us all the bad things that can happen as a result of the blue light. So we say to ourselves, okay, we look at the answer choices, and all the answer choices are in frequency values, right? They're all in frequency values. So really the way to look through this is to say to ourselves, all right, we got to find the frequency of blue light. That's the bottom line. That is the question behind the question. So if C is equal to frequency times lambda, and we know, again, from what we know that C is equal to 3 times 10 to the 8 meters per second. That is the constant value as far as the speed of light is concerned. If we want to be solving for lambda, we would say the 3 times 10 to the 8 divided by the frequency is going to be what we want to be looking for. We know that blue light has a lambda of 400 to 500 nanometers. That's from our content knowledge, right? So I'm trying to instill in you the way that you have to train yourself to do well on the MCAT. So blue light, its lambda value is between 400 and 500. We got to solve for a frequency here. So we're going to turn around and we're going to say, all right, I'm going to say 450 nanometers. We'll pick a number in the middle. So if we were to rearrange this and say that frequency equals 3 times 10 to the 8 divided by lambda, which is also true, that's what we have over here. We have 3 times 10 to the 8 meters per second divided by a lambda value. We'll say 4.5 times 10 to the negative 7 meters. That's 450 nanometers. Now it's a matter of solving this. But here's the hard part. You don't get a calculator on the MCAT. So how am I supposed to solve this? Well, 3 times 10 to the 8 divided by 4.5 times 10 to the negative 7, that looks bad, right? It's not a fun exercise to do. But let's just break it up. Let's just look at 3 divided by 4.5. 3 divided by 4.5 is not an easy fraction. But if you thought of it, that 3 was actually 1.5 plus 1.5. So 3 is 2 1.5s. How many 1.5s is 4.5? How many 1.5s is 4.5? This is the way that we think about this. We're not worrying about the exponents just yet. We're not worrying about the exponents just yet as far as the powers of 10 go. Think about the 3 divided by 4.5. It's 4.5 is 3 1.5s. 3 is 2 1.5s. So really, this coefficient here is 2/3, or 0.66. So this frequency is going to be 0.66, and then we got to work these out. So you have 10 to the 8th divided by 10 to the minus 7. We're going to take 10 to the 8th, and we're going to subtract minus 7. So if I subtract minus 7 from 8, that's like I'm adding 7. So really what we have is 0.66 times 10 to the 15, which is the same as saying 6.6 times 10 to the 14. Now, we look at the answer choices. We don't have an answer choice that is 6.6 times 10 to the 14. But we have an answer choice that is 6.3 times 10 to the 14. And that would be our correct answer. And I see about 73% of you have now chosen that answer, right? So initially, a number of you had chosen answer choice B, but you reread the question and you think it through. Really, now it's 87% of you, even better. So the correct answer is answer choice D, right? That's the one you're going to want to pick, and that's the one that's going to get you the points on the MCAT. Here's something fun. We like to have fun here, so I'll give you a green star. So nicely done on that one for sure. Cool stuff. If you've got questions about that or how we got there, by all means do let us know. But let's take a look at the second learning goal here, and that is everyone's favorite that we saw from before. We're going to take a look at good old ray diagrams. I see from the chat here, you guys like that division trick. That's actually a trick that you can use quite frequently on the MCAT. They do that a lot. And then the other good news is, what I failed to mention, is that you can approximate. You can approximate all over the place. Physics is another good example of this for little g, the acceleration due to gravity. We know that to be 9.81 meters per second squared at sea level. Just use 10, right? Just use 10. Because, again, as Mary even says here, round your hearts out. I love that phrasing. I'm gonna steal that from now on. Right? Round your hearts out, because really that is what it is you're not being tested on significant digits. Right? That's not what this exam is about. This exam is about your abilities to take the content that you know and apply the content to the situations that are being given to you, and reason out an answer choice. And they're not going to ding you on a misplaced or being off by 0.0001, for instance. They will ding you on a misplaced decimal point. Don't get me wrong, but they're not going to force you to get it down to the thousandth place or anything like that. Okay. All right. So with that said, let's take a look at the second learning goal, which is all about ray diagrams and understanding how light rays actually operate. So the first thing we want to look at actually is the notion of reflection. Okay. So when we think about a light ray, so my little blue line here, this is my light ray. Here's my light ray coming in, and then it's hitting a reflective surface, nice flat reflective surface, and it's going to bounce itself off. We call this vertical line here the normal line, right? So this is that vertical line that we are looking at always. And when we measure the angle, this is an area that a lot of folks mess up, so I don't want you to mess this up. We are not measuring the angle from the ray to the horizontal surface. You're always measuring the angle from the ray to the vertical line. Okay, this is the angle that we care about. So we'll define that as theta. So we're always relative to normal. We'll call this theta 1. We'll call this theta 2. In a reflection, theta 1 equals theta 2. All right, so theta 1 equals theta 2. That is always true. That never changes. That is a fact of life when we're looking at a plane mirror. This is called the law of reflection. A plane mirror always create virtual images. And you probably looked at a plane mirror this morning. All right, you probably looked at a plane mirror this morning. So what was the plane mirror that you looked at? Or maybe you looked at it earlier today. When you looked in the mirror and you were brushing your teeth, combing your hair, right, getting ready for the day, that's a plane mirror. The image of yourself that you saw is not a real image. It is a virtual image. And what we mean by the virtual image is that it is inside the mirror, right? So when you look at yourself in the mirror, right, combing your hair, brushing your teeth, doing whatever, you are not actually seeing a real image. You're seeing a virtual image of yourself. It is inside the mirror, and it is upright, right? It is an upright image. So this actually opens up point of conversation number one, as far as the as far as this is concerned, and that is that, bottom line, what we have to be thinking about as far as mirrors are concerned is we have to be remembering that a virtual image is an image that is going to show up upright, right? A real image, as far as mirrors go, will be inverted. But those real images are not going to be in front of you. Where are real images going to be? Where is a real image going to end up? Usually, or ideally, it should end up in a very, very specific place. If you're looking at a mirror and you see a real image, where do we have those show up? This is a bonus question, kind of warm-up question, same place as the light. It's going to be behind you. It's going to be behind you. So now the question is why? So let's take a look and see why that is going to be true. So here is a mirror, and this is what we refer to as being a concave mirror, not convex, concave mirror. So notice that we've got this little concaveness that is coming into place here. We've got the focal point, so we define this distance as being little f. We've got the radius of curvature, so we define that as being r. We've got the object that we're going to place, so we're going to call this distance O. And surprise, surprise, we have the image, which we're going to call that distance little I. So you need to be familiar that O represents the distance of the object, F represents the focal point, I represents the distance of the image, and R is the radius of curvature. Okay, these are the 4 letters, the 4 distances you're going to need to be familiar with. Now there's a reason why we've got them in blue and we've got them in red, and you're going to see the reason why here in a second. But as we're calculating things out, there are a couple of formulas that you definitely need to know. The first is the focal length formula. The focal length formula is going to be equal to 1 over f, so 1 over the focal length, equals 1 over the object length plus 1 over the image length, which is also equal to 2 over r. Okay? So 1 over f equals 1 over O plus 1 over I, which is equal to 2 over r. Memorize this as far as light and optics and as far as ray diagrams are concerned. Okay? Similarly, magnification, whether or not the image is magnified or minimized, is going to be equal to the negative of I over O. Now, the negative is an important part of this because that's going to help us tell whether or not the image is virtual or real, whether it's inverted or it's upright, right? So that little piece is going to give us a lot of information. So in fact, if you had these values, you could calculate the magnification of something. You could calculate what the image distance is, right? If I give you the F and I give you the O, you can figure out what the I is, right? If I give you the I and the O, you can figure out what the M is, right? All these pieces can be solved for as you're going through this. So something to keep in mind, something to take into account. So a concave mirror is also known as a converging mirror. And what the definition of converging means is that the light rays will converge upon each other, right? So you got like 2 converging roads, right? They will converge upon each other. A convex mirror, on the flip side, that is a diverging mirror, right? So the light rays are going to diverge away from each other. So you converge or you diverge, right? But you're either concave or convex. Now this is true for mirrors. We're going to get to lenses later on, but for mirrors, this is what we need to remember and what we need to know. We'll worry about lenses here in a little bit. So let's go through the various scenarios of our mirrors. All right, so we're going to start off with an object. We're going to place it between the focal point and the radius of curvature distance. So we're going to place the object over here. And with that said, we're going to draw 2 rays. And this is what you're going to do every single time. you're going to draw one line that is parallel to the axis. So that's this guy here. And it's going to reflect back through the focal point here, right? This F value is where it's going to reflect back through. So the way you draw this line is you literally just say, okay, parallel to this line down here, I'm going to draw a straight line, and then it's going to reflect back through the focal point. That's my second line, okay? At the same time, you're going to draw a line to the center of the mirror that reflects back at the same angle. So we're going to go from here down to the center of the mirror. So there's our second line. And then it's going to reflect back. Remember, this angle of incidence here is going to be equal to the angle of reflection over here. So whatever this angle is, we're going to see another angle coming back that way. And as a result of that, we're going to have a point where these two rays converge upon each other, right? They crisscross each other. And where they crisscross, what's going to go here? What is going to go at the intersection of the blue line and of the red line? Give you guys a couple seconds to type that in. What's gonna happen at that point? That is where the image is going to go. Very good, right? That is our image. So there's our image, and notice that it's upside down, so it's inverted. And this is a good thing, because the image is going to be real, and it's going to be inverted, and it's going to be magnified, right? So it's bigger than what we started off with, as far as its magnitude is concerned. And more importantly, it is inverted, and it is a real image. Meaning, if I was looking at this mirror, my image would be behind me, and I would be upside down, right? That's what this is saying. So real images, inverted. That's what we have going on as far as this piece goes. All right. So that's number one. Number two, if you got questions on that, let us know. Okay. But this is that first. This is the first part there. Nas had a question that I see here as far as what part of the diagram gives away that it is inverted, real, and magnified. I'll show you right here. It's inverted, right? The arrow is pointing downwards. It's magnified because this distance here is larger than this distance here, right? The height of the object is going to look bigger. And so that's how we know that it is inverted and magnified. And then you know that it's real because it is behind, right? It is behind the original object. So that's how we know that it's going to be a real, I shouldn't say even behind it. It's on the same side as the object, right? That's the key there. All right. If it's over here, which we're going to see that example here in a second, or a couple seconds, then we're dealing with a non-real image called a virtual image. Let's take a look at the second scenario. You got the same kind of setup. You've got the object, only this time you put the object onto the focal point. Same rules apply. We're going to draw a line from the object to the mirror, and we're going to draw a line from the mirror through the focal point. And then we're going to draw another line from the top of the object to the normal line, and then we're going to have the same angle of reflection as the angle of incidence. These lines are now what to each other? I'll give you a hint. It starts with P. It starts with P. And that is, of course, going to be a good old parallel line. Yeah, it's a parallel line. So we got a parallel line here. So this image, these lines never cross, right? They will cross at infinity. So we will say that this image is real at infinity. If you ever get to infinity, let me know, right? I'd love to go there. I've never been there myself, but they're going to be real at infinity. But at the same time, it's going to be an inverted image, and it is infinitely magnified, right? So really, it is a real image. It's just you'll never see it because it's so far away. It is as far away can be, right? It's going to happen at infinity, and therefore you'll never actually see it, but it is a real image. All right? So that's how you make something disappear. You put an object right at the focal point of a mirror, and if you look, you look over here, you'll never see it. That's what it comes down to. So you can make it go away forever. Okay. So you look at the third scenario, more important scenario here. We put the object in front of the focal point. We still draw the line. Same rules, right? So this blue ray still goes to the mirror and then through the focal point. This red line is still going to go from here to the normal line. The only difference now is that if we were to actually draw the angle of reflection, these lines will never converge upon each other. So we extend the lines a little bit, and this is where they're going to converge. And now this image is going to be upright, right? It's going to be upright, and it's going to be magnified. So we have an upright image on the other side, right? It's inside the mirror. So what kind of image is this? If on the same side was the real image, what kind of image is this one going to ultimately be? Just saw the comments about stunning at infinity. I wish, right? We had an infinite amount of time. This would be a virtual image, right? This would be a virtual image. So this is a virtual image that is upright and it is magnified, right? It's a virtual upright magnified image. Cool. If you got questions about those, let us know. Let's take a look at fourth scenario, which is a different type of mirror, right? It's a different type of mirror. So we had three converging mirrors. This is a diverging mirror. So here we've got the object. It's behind the focal point. We draw the line. We've got the issue now is that we don't draw it through the focal point here since it's a diverging mirror. We draw it through the focal point that is over here, right? That's on the inside of the mirror, if you will. We draw this line. We've got the angle of incidence. We've got that comes in there. If we extend our lines, we would see our image is going to be right here. It's going to be upright. And in this case, since it's inside the mirror, it's going to be a virtual image, right? Virtual image. It's going to be upright and it's going to be minimized. So here's the trend that I hope you have picked up on. When you're dealing with these mirrors, right? When you're dealing with these mirrors, I'm going to take us to the slide over here. If the object is between, right? If it's between the C and the F values, you end up with a real inverted image. If the object is at the focal point, your image disappears, but it shows up at infinity. More importantly, if the object is upright and imaginary or virtual, and over here, the object is upright and virtual. So here's my question to you. Is there a connection between virtual and upright? And is there a connection between real and inverted? What do you think? They are. There is, right? There is a connection between those two. So that is what we know, and that is what we can use to our advantage, right? Use to our advantage along the way. Cool stuff. All right, so let's put this into practice. Let's get some points on the MCAT for this. We've got an object. It's standing 12 centimeters from a diverging lens. If the image is formed 2 centimeters from the lens on the same side as the object, what is the focal length of the lens? So which formula would we want to use here? What's the formula that we're going to have to use in order to solve this little problem? What's the formula that we have to have? Give you a couple seconds to type this in. You got to use the formula for one that's 1 over f, right? So you got to use 1 over f equals 1 over I plus 1 over o, right? That's what we're using. Perfect. You guys got it. So here's the formula, right? Here's the formula. And we've got values, which is great. So we know, according to this, that the image is formed 2 centimeters from the lens. So we say that's going to be -2. We know that the object is standing 12 centimeters from the diverging lens. So that's going to be the value of 12 here. If we solve this out, right, if we solve this out, we are going to end up with a value. Nice, you can kind of move things around. Say 1 over -2 is like saying 6 over -12, right? That's also a -1/2 value. So really what we have is 1/12 minus 6/12. So 1f is going to be -5 over 12. And then we got to invert these, flip these things around, solve for f. We're going to have -12 over 5. So we know that our answer is going to be negative, so we can eliminate answer choices C and D, right? Those can be gone right from the get-go. And then it's a little bit of math. So here's the fun part. Remember earlier I said you didn't need a calculator? You still don't need a calculator, right? That hasn't changed. Think of it like this. You know it's going to be negative, so it's either A or B. It's 12 divided by 5. 5 can go into 12 2 times with a little bit left over. So it's going to be -2 and something. So it has to be answer choice A, right? That's the bottom line, is it has to be answer choice A and has to take it into account from that perspective. A couple of you are asking, why is it -2 and why is it not 2? It comes down to the fact that they told you that it's on the same side as the object, right? So we are given that information. We know it's on the same side of the object. So when we think about the image value as being on the same side of the object, it's going to have a negative compared to the object itself being 12 centimeters from the diverging, from the lens, right? So if you think about a diverging lens, I mean, if you were to go back to kind of what the diverging lens looks like, let me actually just jump us back there real quick so that you can see it. Sorry, we haven't done lenses yet. Hold on, never mind. We'll look at lenses here in a second. I'll show you in a second when we look at lenses. But it's because they told you that it's on the same side. That's what it comes down to. That's the reason why you would use the negative value as opposed to the positive value. We'll see it when we look at lenses here in a second. Cool stuff. Great. So if you've got any other questions, let us know. We're going to flip gears though and take a look at this from the perspective of the lenses, and you'll actually see how diverging lenses have negative focal lengths as opposed to the mirrors, which is what we had been looking at so far. So let's take a look at that and see how that works. But before we do that, let's take a look at refraction. When we are looking at light and we are looking at it traveling through different mediums that have different densities, the light is not going to be reflected per se, but it's going to be refracted, meaning, very fancy word, meaning that it is going to be bent, right? It's going to be a bent piece of light. So here's how we look at this. Let's pretend that we've got air and we've got water, right? So which one is more dense, air or water? Between the two, which one is the more dense medium? Water is, right? So we know that water is the more dense medium. We say to ourselves, all right, here we've got a ray of light. It's coming through the water, and then when it hits the air, it's going to change, right? It's going to change the angle at which it's traveling. It's not going to continue in the same line as it was when it was the water. So if we think about this, and we think about the density of medium, and we think about what we really care about, which is the index of refraction. The index of refraction will cause the light to bend more towards this normal line. Right? This normal line is absolutely key. So as we go from water out to the air, notice that this angle here is smaller than this angle over here, right? We bend more towards this normal line. This angle gets smaller, it gets bigger when we go up into the air. So there is a formula for this, and that is Snell's law. Snell's law tells us that the index of refraction times the sine of theta 1 is equal to the index of refraction of theta 2, the index of refraction n2 times theta 2, right? So this should actually be, I don't know why that's wrong, but it is. So we're going to fix that real quick for you. This should be a 2, right? And we'll take it from there. Okay. So really what we're doing is we're basically trying to figure out, right? The two halves are going to equal each other, but it makes sense, right? As one angle is getting bigger, the other one's going to get smaller. So the sine values are going to change because the n values are changing, right? The index of refraction goes up, so the angle goes down. The index of refraction goes down, the angle is going to go up. What also happens in all of this, of course, is as we're refracting this light, as we're bending this light along the way, what's really happening at the end of the day, of course, is that we are causing the light to go in a different direction. So this is why, if you put a pencil, I think the classic experiment is usually you put a pencil into a beaker of water. You'll see the pencil bend, right? It'll look like it's bent in the water, even though the pencil itself is not actually bent. It looks like the pencil is bent. The other thing to keep in mind, though, is that air is pretty much going to have your, it's going to have your, as far as light is concerned, or as far as the index of refraction is concerned, it's going to have the lowest value. Everything else is going to have a bigger value of that, because air is pretty boring. There's not a whole lot that's in the air, if you will, as it were. Cool. So let's take a look at this from the perspective of lenses and ray diagrams. So we've got our object. Difference with a lens versus a mirror, of course, is the light is traveling through, right? So we've got the object and the image are going to end up on opposite sides, in these converging type situations. So same rules as before. We're going to draw two rays. We're going to draw a line that's parallel to the axis. The only difference now is we're not going to do reflection. We're going to do refraction, and the refraction is going to occur through the focal point. So in comes the line, right? So here it is, and we're going to refract it through the focal point. We're going to draw another line that's going to go straight through the center of the mirror, right? So we've got the blue line and the red line, and where these two lines intersect, again, that is going to be where your image is going to end up, all right? And so in this case here, the image is inverted. What kind of image is this? We've got an inverted image. What kind of image is this? We've seen this before. Nothing has changed. This is a good old real image, right? So the image is inverted, and that's what it comes down to. So this is actually how we see, right? If you've got an object that's pointing upwards, what we're actually seeing on the back of our retina is upside down. Our brain flips it back upwards. FYI. So you can go tell your friends that, everybody sees the world upside down, because that's technically how we're seeing it. It's our brain that's flipping things around. But as far as these objects that are hitting our retina, they're upside down, and that's how it operates. So keep that in mind. It is magnified here. If we want to figure out the power, we can just take this and say, all right, there's another formula. The formula is that power is equal to 1 over the f value. So 1 over that focal length, that's going to give us the power as far as the lens is concerned. So when you go, get glasses fitted for yourself, that's really what they're measuring. They're measuring that power because you're getting corrective lenses. They're going to work with your lens, and that's what it comes down to. So a couple things to keep in mind for lenses in converging systems. There really are 3 possible outcomes, right? We care about these 3 possible outcomes. If the O value is greater than the F value, you're going to get a real inverted magnified image. That's the example that's in front of us here. If the O value is equal to the F value, what do you end up getting? We can draw the lines, right? So there's one line. We'll draw another line, right? So we still draw the line that's parallel and then the line that's right through. These lines never really converge. And so what do you end up getting? You get no image, right? So the image is real at infinity. Again, just like the mirrors. It would be inverted if we could see it, but it is infinitely magnified. You really just end up with no image, is what it comes down to. The third scenario for lenses, which is a more interesting scenario, is if you put the object in between the focal point and the lens, and you say, all right, I'm going to draw my lines, and I end up with this, right? These aren't intersecting at all over here. So if you were to extend the lines backwards, you would get an image that is upright. What kind of image would this be? It's an upright image, but how would we define this? Real or virtual? Where would this be? It would be upright and virtual, right? So this is an upright virtual image. That's what we have, and it's magnified, right? It's a magnified upright virtual image. Cool. All right, last little bit here. Last little bit. If we were to take a lens, this time a different type of lens, right? So we've got another scenario here. We're looking at this and saying, all right, we put the object and we're going to draw my line, and I'm going to draw a line from the focal point up through, because this is a diverging lens, right? These were, going back real quick, these were converging. These lines converged upon each other. This is a diverging lens, right? So the light rays are going to be diverged outwards. So we draw the line from the focal point through the center lens. We draw from the top of the object through the center over here, and we end up with an object that's the intersection that's right over here. That's where that image is going to be, and it is going to be minimized, right? This is a minimized type of image. It is virtual, it is upright, and it is minimized. Right? That is what we are seeing as far as this little lens is concerned. This is a diverging system. Any diverging system that you get on the MCAT, you're going to get a virtual upright minimized image. Bottom line, it's always going to be the case. So if you see a diverging system, just choose the answer that is virtual and upright. Right? That's what it comes down to. So there's almost no work that has to be done, and that's going to help you help you quite a bit. So it's going to be always going to be the case. You don't have to do much more with it. Really, is what it is. It's easy to kind of get caught up in in other things and get caught up in all the rigmarole that's there, but really not worth your while to do anything more than that as it were. Cool stuff. All right, let's test our skills out. So I'm going to give you guys a minute, and I want you to try question number 3. So we're going to put that up here on the screen. So go ahead and try this question. This is it's a good question for you to try out. So take a minute, try it out, and put your answers into the polls. Alrighty, so that's a minute. I see that about 70% of you have chosen answer choice A with some migration that's happening here as we go. But let's see what we can solve here for this. So if we were to look at this, it says, okay, light ray wavelength 600 nanometers enters a piece of glass with an index of refraction of 1.5. Which of the following best describes the path of the emerging ray? So we're going from air to glass and then back out, right? That's really what's happening, is we're going from air to glass and back out. But more importantly, we say, okay, here's our angle of incidence. Here's Snell's law. So n1 sine theta of 1 equals n2 times the sine theta of 2. We know that the index of refraction of the air over the index of refraction of the glass is going to equal the sine theta of the glass over the sine theta of the air, right? So if we were to say air is 1 and glass is 2, and we rearrange these, this is the ratio that we would be getting at the end of the day. So the way to do this math, and it's not even math that you have to do because you don't have a calculator to solve this out, what you do know is that the index of refraction of the glass is greater than the index of refraction of the air because everything is greater than the air, which means that the angle, right, the theta values are going to have to be the other way around. The angle, the theta value for the air is going to be greater than the theta value for the glass. So this ray is going to bend towards the normal glass. And then when it comes back out of the air, or back out into the air, it's going to bend back to where it was originally. So the real key here is to find an image that has the ray bending towards the normal line and then going back to where it originally started. So let's go through these. A, it bends towards the normal, then it goes back to where it originally started. Same exact angle as, from before and after. So that one's going to work. If you look at B, it bends away from the normal line, so you can get rid of B right from the get-go. If you look at C, it stays the same almost, maybe bends a little bit, but then it bends a little bit more when it comes out. That doesn't make sense. And then with D, it bends away from the normal line and then back towards the normal line. It would be the other way around. So the only answer that could work here is answer choice A, right? So just be mindful of that it's, it's about how you perceive these. Notice there was no math that had to be done. These numbers, I want to kind of call this out here because this is very typical for the MCAT. Very, very typical for the MCAT, where they will say things like light ray 600 nanometers, index of refraction 1.5. You know what? You actually didn't need any of that information. You didn't use the wavelength at all. And all they had to do was tell you that it wasn't air, right? It didn't matter if it was glass or water, whatever it might have been, it's going to be an index of refraction that's greater than air's index of refraction. Air's index of refraction is close to 1, right? It's practically 1. So bottom line is, you don't need these numbers. Don't get fooled into thinking that you have to do calculations because most of the time, you won't need to. There are very, very few cases on the MCAT where a calculation is absolutely required. Absolutely required. But in this case here, no math, right? No math needed, and you're able to get to the right answer just purely by knowing your concepts and knowing how to apply those concepts. Because what did I say earlier? I said you got to know how to apply concepts in order to do well on the MCAT, because it's all about the application of that material. That is the key. That is the way that you're going to be gaining points, and that's how you're going to be getting the scores that you ultimately need. All right? So here's what we've done. We've looked at a couple of topic areas, and these aren't necessarily easy topic areas, right? So, for those of you that are going to be testing soon, definitely review this stuff. But, for those testing a little later on, you have some more time to make sure that you review this material. But the key to understand here is that as important as knowing the content is, it's just as important to know how to apply that content, right? So really, what we've done so far here is kind of the beginnings of your practice with this. Now it's about, doing more problems that relate to these types of content areas so that you really can become kind of a master at these pieces. That's a big part of the MCAT. It's a huge, huge part of the MCAT. It's about practice. I mean, there's a reason why we encourage our students to practice so much, right? There's a key to it. There was a great question that came in from Neha about the diagrams. Is our recommendation, the question was, do we recommend drawing the diagram out? And the answer is simple. It's only if you need to. And that's true for anything, not just for ray diagrams. That's true for anything that you're working on, any scratch work that you're working on for the test, only draw out the things that you absolutely need to in order to be able to solve the problem. Now, if that'll help you, that's great, use it, but also recognize that that is taking time away from you being able to solve this problem or another problem. So, really, really important to make sure that you're only ever, writing stuff or doing things that are absolutely necessary to get a question right. And I think that's really easy to forget sometimes, and really easy for us to, kind of fall into those bad habits of just trying to draw everything out. But, keep that in mind. Just do the work that you need to ultimately be doing in order to be able to solve the questions. Cool stuff. So, lots to study, lots to worry about, lots to work on for sure. But really, with there was, I think, a couple of you were concerned about all the memorization that has to go into place. There is a lot of memorization, but as I said earlier, the more you practice with this material, the better you will become at it. Like, really a lot better. And in fact, you'll get to a point where you're not even memorizing formulas anymore. You're learning formulas from actually doing problems. I think that's actually the best advice somebody ever gave me, and I'll pass it along to you, that the way to learn this stuff is to really just practice doing it, right? So this is the key to keeping that in mind. So keep that going, and remember that always as you're looking at the different content areas, regardless of what those content areas are. Okay, really important to keep that going. Now, when you're studying, you might need a little boost of caffeine, or if it's not caffeine, then it's sugar, or if it's not sugar, then maybe it's just a nice, nice drink of some kind that you can get at Starbucks. So that's my shameless reminder to you to fill out the chance to get a gift card from Starbucks. So go ahead and click on the link that's at the top there. This is we'll give you one last chance. But as you're doing that, what questions do you have as far as studying for the MCAT, getting ready for this thing? Let's talk. Let's figure out kind of what goes on. Claire, you've got a great question. I'm going to answer that in a little bit here, so hang tight. Claire's question is going to be answered. It's actually a great question. But what questions do you guys have in terms of getting ready and getting studying and making that happen, and what it is? Because this is what we're here for. So we're going to spend the next 20 or 30 minutes or so just figuring out what's right for you, right? Because that's what's important. But I figured we'd open it up with an open question. Actually, Claire, I will answer your question right now because now I can see the whole thing. Do you suggest more time on practice tests than on content review? The answer is yes and no. And here's what I mean by this. Earlier on in your preparation, you are going to be spending much more time reviewing content than you are going to be spending time doing practice tests. Okay, that is just the way that this works. The reason for that is that you have to build up your content knowledge. But the way you build up your content knowledge is by reading material, by coming to sessions like these, coming to the MCAT channel, watching our science review videos, right? You're going to be doing a lot of content building. The way that you retain the content, though, is you practice using it. So earlier on in your preparation, think of the content as being kind of the big piece of the graph, with a little bit of kind of questions to reinforce that which you have learned. As you go further and further, closer and closer towards test day, you're going to be doing less of the content review and more of the active practice, and only going back to content when you need to. And you need to kind of fill in some gaps along the way, right? When you're struggling with something, or something isn't quite clicking and you're like, all right, let me go back to the drawing board. Let me see what's going on. So as you get later and later in your preparation, you're going to be doing almost no content review, and it's all going to be practice and with like little bits of content review. So I wouldn't say that one is more important than the other, but I will say that depending on where you're at in your MCAT preparation, you're going to be doing more of one versus the other. The worst thing that you can do for yourself, this is true for everybody, is to start taking full-length exams right when you start studying for the MCAT. Right? That is not a good strategy at all. right? That is a horrible strategy, in fact, because you're going to sit there and going to go, I don't know any of this stuff, and you're not going to do well, and then you're going to feel bad about yourself, and it's not going to be great. So don't do that. Let's talk about kind of, starting points. I think the most important thing that you can do for yourself, if you haven't already done so, is kind of know where you're at. So take a practice exam, see what your score would be, figure out what your strengths and weaknesses are. When you're in one of our courses, you take a diagnostic exam. We actually analyze your performance, not just on a diagnostic, but on a science diagnostic as well, and make recommendations for you as far as what it is that you should actually be focusing on, where your individual focus is. Everybody has different strengths and weaknesses, and we're gonna need a little bit of time to figure out what we each need to do, and that's what our recommendations engine, it's called Smart Reports, that's what it does, is it tells you exactly kind of what your individual needs are as a student. So that's, I think, step number one. We oftentimes forget about that step. Really important to make sure that you kind of know where you're at and where you want to go to. The other big mistake, and I'm very sad to say this sometimes, but the key mistake that a lot of students make earlier on in their MCAT prep is they review their old textbooks. Textbooks are great for your college classes. They are horrible for the MCAT because they contain far more information than you are actually responsible for. So like our review notes has all the information that you're responsible for as far as the MCAT. I get this argument a lot from students. I shouldn't say argument, but students come up to me like, Petros, my instructor, they emphasize topic X, Y, and Z, and you don't have it in the materials, or you didn't teach this to us in class. It's like, no, we didn't, because it's not tested on the exam, right? The way that our course is built against the blueprint of the exam, and beyond that, you don't need to worry about it, right? You can worry about it afterwards, but don't want to worry about it as far as the test. So really important to make sure that you're doing those things. Also, making sure that you build out a study plan, and that is both realistic, but also targeted to what and personalized to what your individual needs are, so that you're not studying things that you don't need to be studying. I mean, give you an example. If you're a rock star at thermodynamics, you don't need to do a lot in thermodynamics. Just do some practice. But if you are horrible at, light and optics, like we looked at tonight, and you have no time planned for doing light and optics, you're not going to have a good outcome, right? So you need to make sure that your study schedule is personalized to what your individual needs are. Don't just look at, what others are doing. You really need to get the drills. You need to get the realistic practice in. That's what's going to help you raise your score. We generally recommend having access to at least 6 full-length exams. There actually are 15 in our course. That includes 4 from the AAMC. I say 3 because one of them is unscored and really shouldn't count, but it's there. It's the 15th exam. So it's important to get that practice. What's also important though is to give yourself time between taking full-length exams. So you don't want to just take full-length exam after full-length exam after full-length exam. What you want to be doing is you want to be taking a full-length exam and then reviewing the content accordingly, and take it from there. So you're doing the work that you ultimately need to do. And then of course tap into all the sources of expertise that you can. I mean, when you're in our class, you'll have your instructor, you'll have your channel instructors, you'll have your team of teachers. If you take a plus course, you'll have your MCAT expert that will guide you through the material. So you're going to have lots and lots of opportunities, as it were, to kind of take those things into account. So really important to kind of keep that, as it were. I saw a couple of questions that came in as far as like what's enough for content review. So Prasan, you asked, are the Kaplan books alone enough for content review? The Kaplan books that you can buy at on Amazon or the bookstore, it's called the 7 Subject Review. It has 7 books in it. Surprise, surprise. 1 on each subject. That will cover the content. Yeah, absolutely. That will cover the content. What it won't give you is the practice. So we've got the 7 subject books. Those you can buy on their own. They're available. I think they're they're definitely on Amazon. They're in other places too. Those are included with your course. So if you are planning on taking a course with us, don't feel the need to go and buy the 7-subject review, you're going to get that. So as soon as you enroll in the course, we'll send you that send you those materials. But beyond that, what you really need is a lot of practice. There's a reason why we have over 10,000 questions as part of our course. It's because we want you to have exposure to as many questions as possible so that you can spend time working on the stuff that you need to work on. Again, you need to fixate and focus on the material that you individually need. So that's why we have all those questions as part of our course, as well as the 14 full-length exams that are part of that. You have access to all the AMC materials. So just FYI, if you're planning on taking a course with us, do not go and buy the AMC materials because you have access to all of those as part of our program. If you take a plus program, then you'll also get a personal MCAT coach, which is kind of like a personal trainer, right? That's really what it is. It's a personal trainer that will work with you to kind of figure out what you need to work on, in addition to what the recommendations are ultimately showing you. But to be clear, everybody gets the same stuff regardless of the way that you decide to take a course with us. That includes the MCAT channel. I alluded to this earlier. The MCAT channel, it's really cool because it's kind of like MCAT Netflix. It rotates on an ongoing schedule. The sessions are always live. They're also recorded, but they're always live. So you have access to the recorded versions, I should say, but they're delivered live. There are top instructors, literally our highest instructors at Kaplan are those that teach on the MCAT channel. And really what you do is you go through some of those highest yield content areas, and you can customize it to really focus on your areas of opportunity. So it's one of those cases where you're able to say, this is what I need to work on, this is what I'm going to work on, and I'm going to do the work accordingly. There was another question, Nia, from you as far as how to keep a balance between knowing everything and looking in the passage for answers. Can you find answers in the passages? The answer is, for passage-based questions, there is some part of the answer that is going to rely upon information from the passage, whether that's the direct answer or a clue in the passage that you will then use with a formula to solve out the actual answer. So yes, you will need the passage. The reality, though, is the passage alone isn't going to get you the answer. The content knowledge alone is not going to get you the answer. So that's why the two skills are so important, the critical reading and the content knowledge. Even more so, though, what's important to keep in mind is that, on the critical reading section, the cards section, there is no content to fall back on. So that is all going to come from the passage, but it's not a reading comprehension test where it's, oh, I remember them saying that. It's a critical reasoning exam where you have to draw conclusions based on the information that was presented to you. So you have to kind of practice that skill along the way. Part of practicing that skill, actually, you can do, remember I said we have 10,000 questions. This is actually wrong. It's 15 full-length exams, not 14. But part of those questions are in our quiz bank. And the quiz bank, the way it's set up is it's about 2,500 or so questions. I think it's at 2,600 now. And what is in there is an opportunity for you to, one, select the topics that you want to be working on. Select the number of questions that you would like to work on in a given sitting. And then you create a customized quiz. And what happens in the QBank, it's actually this new feature that we have in it. It's adaptive. And what it does is it literally will adapt to your level of difficulty. So it always keeps you in kind of this optimal zone of performance. The reason why you want to do this, kind of like strength training, you don't want to try questions that are too hard for you, because then you won't actually be learning anything. You don't want to try questions that are too easy for you, because then you're not going to be learning anything. You want to try questions that are just challenging enough to you. And as you improve and as you do more and more work, those questions will naturally progress and become more difficult. So the quiz bank allows you to build those customizable quizzes, but it allows you to build those customizable quizzes and get get practice in that kind of perfect zone that it comes down to. So important part of this for you to kind of keep in mind as far as how it is that you're going to ultimately be studying, because it's so easy. I think that's the advantage really of what we do, is we look at and say, all right, we're going to help you figure out how to do the studying, make your time most efficient. All you have to do is do the studying, right? That's the easier part in this, is just to do the studying. The Smart Reports actually helps you do that. So what Smart Reports does is it actually assigns you homework. It says, here's your area of strength, here's your area of weakness, here's what you got right, here's what you got wrong, here's the recommendation of what you should be working on next. So the Smart Reporting system is actually actively making recommendations to you of what work you need to be doing, as opposed to you having to figure out, what should I do? Who's had that problem when you're studying for a class? It's not so much the material that's hard, it's figuring out what to study that's hard, right? Or figuring out what's going to be tested, or where it's going to be tested, how it's going to be tested. That's what can be challenging. And so really kind of, giving yourself that opportunity is where you're going to see the best results, if you will, along the way. Cool. Last couple bits here, just a couple things I wanted to share with you. And I see some questions that have come in about this, so we'll just answer this as a blanket statement here. The programs come in a lot of different ways. We've got live online, we've got in-person, we've got self-paced, we've got private tutoring. Live online is just that. It's live instruction, but it's an online classroom. It's interactive, just like this classroom here. In-person is you go to a traditional classroom location. Self-paced is you study on your own. Private tutoring is you have a one-on-one instructor to take you through it. But lots of different options. Couple things. If you are thinking about taking a course with us, one of the best things to do, of course, you can go to our website. It's all explained there. There's this chart that you can look at, of course. But more importantly, if you click on the link at the top of the screen, you can actually set up a time to speak one-on-one with one of our MCAT experts to get all your questions answered about what is the right option for you as far as your coursework goes. So I would encourage you to do that. That's a great opportunity to kind of figure out what the right course is for you and when the right time is to begin studying, quite frankly, right? So because you might be thinking, oh, I should start 2 months at a time. You realize, oh no, I need to start 5 months at a time or 4 months at a time or whatever the ahead of time might be. So definitely I encourage you to do that. For those of you that are planning on prepping this summer and need a little more of an intensive experience, we have our intensive programs, and they occur either live online or in person. They're a little different from our kind of traditional prep courses in that all of your time is structured. So very, very different experience. This is one of those cases where you would want to be doing nothing else if you were planning on doing one of our intensive programs. So if you're interested in those, also click on that link at the top of the screen, and we'll be more than happy to answer those for you. What other questions do you guys have? I've only seen a few more that have come through, but any other questions that we can answer? And you've literally got you've got the team here. This is the Kaplan team. So what questions are on your mind as far as preparing and doing the right things at the right time? What can I answer for you? Because that's what we want to do, is we want to answer all the questions that we can answer for you here. So let us know what those are. I see one. It's an interesting one of whether or not we offer anything beyond MCAT in terms of medical school admissions. And the good news is we do have admissions consulting. So if you are, if you've already you're kind of getting close to test day and you're already thinking ahead to, well, how do I get into med school? We've actually got a whole suite of admissions consulting options available. You can either work one-on-one with a consultant, or you can do, we have a kind of a self-paced version. So if you go to our website, go to kaptest.com/MCAT and click on admissions consulting or admissions help, you can do that. You can find out more information about those for sure. Jesse had a question about your test date is a month away. You've read through all the books, or through 3 of the Kaplan books. What should your game plan be going forward? Game plan going forward, it's true for everybody. Start getting practice in. Reading those books with 1 month out is not going to be the solution. It needs to be that you got to get practice in. So if you just need practice, you don't want to buy or you don't want to get the stuff from the AMC, or you don't want to get a whole course with us. We also have our practice packs available. So you can purchase just 3 full-length exams if you needed that, and you can there's those options. Hannah, your question to you: are you able to purchase certain components of the course? You can't. The MCAT channel, unfortunately, that's exclusive to the course. That is not available as a standalone today. We do have the QBank that is available as a standalone, so you can just get that. You can actually choose the duration of time that you want for the QBank. We have some of the science review videos available as a standalone. We have the full-length exams, 3 of them, not all 15, just 3 of them, available as a standalone as well. So, there is opportunity to get those components. If you go to our website, go to captest.com/MCAT, you can see what all of those are. We've got a couple of different bundles that are available as well. So something to keep in mind as well. Miguel, great question as far as the advantage of the question banks versus taking practice exams. The advantage is time. So if you are, one, you always want to be doing practice questions, but you don't need to be doing them in 7-hour settings all the time. So the question bank is just that. It's, okay, let me do some questions to get the practice that I need. The practice exam builds your, it helps you practice, obviously, questions, but it also helps you build your stamina and your endurance. So you don't want to be doing a full-length exam every day. You're probably going to do 5 or 6 by the time you're done with this. So, the question bank and then the other practice questions that we have as part of our course, those are there for your practice, right? They're there for as a kind of mini practice along the way is what it comes down to. So that's the bit there. Jesse, let me know if we answered your question as far as your game plan for the next month. It's time to be practicing for sure. Read the content that you need to read, but don't just read it all on its own, right? Really important to kind of keep that in mind as well. Another fun thing just to be aware of is, even if you're planning on preparing for the January exam, now is technically not too early to get started, or even if you're thinking of taking the September exams. Bottom line, the way it looks as far as the MCAT goes is that there is a burnout point, but that burnout point is not 5 months. So if you're thinking of taking the test in January, you can start now, kind of start getting, get your access going, get your books, start some kind of pre-work, if you will, and then, start studying in earnest in the fall. If you're planning on testing in September, but you don't want to start studying until the summertime, you can, again, get enrolled, get your books now, and, kind of get warmed up, if you will. The one thing I will say is don't start forming bad habits. This question came up last night of, what should I do before I start studying for the MCAT? What should I study before I start studying for the MCAT? And my answer was don't form bad habits, right? Don't form bad habits. We got a question about tutoring and how it works. So tutoring is really awesome. Basically what we do is we pair you up with a MCAT expert who will work with you on the subject areas that you have identified and that have been identified through your SMART reports, through the recommendations. You basically have to pick how that works, what you want to be working on. Our tutors will make recommendations for you as well. You're paired up with somebody. We give you a little bit of a survey, kind of get to know you, kind of what you're looking for in the tutor, the areas that you want to be working in or working on. And then, whether you're doing in person or you're doing live online tutoring, we'll pair you up with somebody as far as your availability and your schedule. So it's really, really nice. You got nice one-on-one attention. And at the same time, you get to work with somebody on an individualized basis, but you also get the class, right? You get the class at that point. So really, really great little opportunity. The nice thing about tutoring is that it's, the course is extremely customizable. It's personalized to what your individual needs are. What tutoring does, it takes it even one step further and lets you, customize it and work with a teacher in a customized fashion, right? So really, really a great opportunity for you from that perspective. So something to think about, something to consider, and take it from there. An example of a bad habit. I'll tell you 3 examples of a bad habit if you want. One big bad habit example is you start studying for the MCAT and you treat MCAT questions the same way that you would treat questions in problem sets for your undergraduate classes, meaning you try to do the long calculations and you're not actually solving the problems using the critical thinking skills that you need to be using. Because remember, this exam is not about finding the precise decimal, thousandth digit per se, like it would be in a chemistry class. It's about solving conceptually for the answers. That's one of the biggest mistakes. Second mistake is just reading the books and not actually doing any type of reinforcement. Reading the books is a great first step. It is a passive exercise. It does not reinforce the material that you have. So very, very, and that's really an easy bad habit to fall into. And then the third one is taking full-length exams without actually having the guidance of knowing how to review them and not having the right types of explanations, levels of explanations to guide you through them. So, all 3 things that are easy to do on your own, right? It's easy to go get practice tests. It's easy to, read the books. It's easy to solve things, but not do them the right way, because it's going to take a lot of work to unlearn that. Oftentimes, the way that I will start off my courses is tell students, you got to unlearn all the stuff that you've learned, because you got to be thinking completely differently, right? This is an exam that's going to require you to think in a new and a fresh way, which we oftentimes forget. So that's the bit there. Cool. All right, so I know we're wrapping things up, so I think it is time for us to select Michael Lockhart, who has been selected to receive the $50 Starbucks gift card. So Michael, nicely done. We will be in contact with you within about 48 hours or so. So we'll get you the information and get you your gift card. Sorry to everybody else, but Michael, maybe you can share your gift card with some of your friends who are also studying for the MCAT. With that said, I wanted to take this opportunity to thank Ari, Ashwarya, Greg, Mary, Mike, Nikolai, and Rich, who've all been here tonight, making this happen for all of you. Great colleagues as always, so thank you. Big thank you to each of you for being here. You guys were awesome. You did great work. We're going to stick around for a couple more minutes and answer questions that you have. But if our paths don't cross again between now and when you take the MCAT, especially those who are taking the MCAT this coming Friday, we wish you the best of luck. Really want you to do well in this thing, and take it from there. So good luck to those who are taking the exam. We'll stick around to answer any questions that you have about our courses or about the MCAT and getting ready for the MCAT as we go. But other than that, have a great rest of your evening, everyone. Megan, great question. How do you review properly? I'm assuming you're referring to reviewing full-length exams. So I'll answer the question in both ways. So reviewing full lengths, yeah, okay. So the way to properly review a full-length exam is you go through the entirety of the full length, you mark down why you missed every question that you missed. So the topic area, the type of wrong answer that you selected, and the reason why you missed it. You also want to go through the questions that you got right, because you might have gotten some right by luck, or there might have been a better way to go through those problems. Once you've done that, you identify the patterns of where you need or where your areas of opportunity are, and then go focus on activities related to that, whether it's content review, question practice, before you take another full-length exam. So a big mistake a lot of students make is they take a full length on Monday, and they go take another full length on Wednesday, and they didn't do any type of review on it on Tuesday. That's not going to improve your score. So don't do that. Don't do that at all. And that's the, that was the 30-second version of how it all works, but it gives you the general gist of it. All right. If there are any final questions, let us know in the chat. Otherwise, have a great rest of your evening. Diamond, great question. Do you need to finish the content review before you take your first full-length exam? I mean, not really. Technically, you don't need to. Just recognize that you will have a slightly lower score potentially because of content areas that you haven't yet covered. So don't get discouraged by that full-length score, I guess, because it's easy to get discouraged by it if that's the case. So, it is, it's important. It's important to finish as much of the content, I should say. But at the same time, and let me ask you this, how far away are you from test day? Because that will change my answer a little bit. So let us know how far away you are from test day. I guess this is what I'll say is that if you are, if you're close to test day and there's still some content you haven't done, start taking full-length exams because you don't want to delay that too much. But, make sure that you're covering the topics that you need to be covering and you'll be good to go. And you're all very, very welcome. I saw a bunch of thank yous come in earlier. You're all very, very welcome for sure. Thank you for being here. All right. Well, with that said, again, we'll say our goodnights. If you have any final questions for those of you that are still here, by all means, do let us know. Otherwise, have a great rest of your evening. Have a great rest of your week, and best of luck studying for the MCAT. Take care, everyone. And tomorrow night we've got, what is it, molecular genetics, right? So definitely join us. Definitely join us for that. What a swing! Go from light and optics to molecular genetics. Can't have any more extremes than that, I think. It's like one end of the spectrum, other end of the spectrum, as far as the sciences are concerned. No pun intended, seeing that we looked at the spectrum tonight. And yes, there's boot camp on Saturday. MCAT boot camp coming up on Saturday as well. The fun continues all week long. All right. Well, thank you all very much for joining us. We'll go ahead and close up the room. But otherwise, have a great rest of your evening. And thanks again for joining us. See you all here very, very soon. Take care, everybody.